Welcome to this video tutorial about the general workflow of a grid-based DTM generation in Match-T and also in Match3DX. This video just wants to show in a general way these steps shown here in the 5th chapter, and with the data preparation, defining a boundary, measuring morphological data, and how we can then use this morphological data in the processing of a DTM in the feature-based matching processing part, and how we get grid output, and then also finally we will then load the data into DT master and here do some quality check. So in this workflow we are offering the option to do some data preparation, so running a boundary for our project and generating morphological data. This workflow here is just a recommendation. There are many ways to generate a high accurate terrain model. This work process here is one possibility. It's not the only possibility, but we want to show here the functionality existing in Match-T, Match3DX, and also in DT master, just that you are aware what options are possible to be used in this process. So first thing would be to measure the boundary, for example, for the project in DT master. And we will use in this video here the demo data set from the training data CCD. And this is here loading the project file with the complete solution. I renamed it into training data underscore DTM, but this is the complete data set that you can also find in the download. So in these two underscore match AT, you will find here the training data underscore AT underscore complete, and this is the exact same data set with the corrected file paths, which you can correct in the project editor into the frames, and here giving the correct path by selecting here with Ctrl A all the images and giving the correct path. So we load the project into DT master, and you can also run DT master in demo mode, just that you can also review these functions and then just fill up these steps that we do. So then in the terrain tab, we can generate a new file. In this case here, I will call it morph. And for this morph here, we can select a template with here some predefined morphological layers. And then we can select one layer by right-clicking here on, for example, the exclusion areas, and saying set as active, and then we can see this is active. We can then go into the create point line, and then we could start to digitize here a polygon and to extract here our exclusion areas. And the same thing would be with break lines, right-clicking break lines, set as active, then measuring the break lines here and creating break lines. I already did this, so I will here just remove this one, and I will import here some vector data that I created. And in this part here, I will import here this part, and I will just assign exclusion areas to exclusion areas, and my break lines to break lines, and my true auto lines to object shapes. Here we go. Then I will give exclusion areas yellow color, break lines red, and true auto blue. And then we can see here these exclusion areas have been here digitized. And when I take a look here at the aerial images, then of course I can digitize them in stereo, or I can also just use here an orthophoto as a backdrop and measure the exclusion areas from this part. Same thing was done with the borderline or with the our project area. So again, here I import some vector data, and I will import here this DTM area, and then adding here as a borderline and making this borderline here in purple, closing the stereo window. And then we see this would then be my project area where I want to generate my terrain model inside. And in this case, to showcase how these exclusion areas will help to generate a terrain model without the buildings in this part here. Just perhaps loading again a stereo model. We see here, this is a city area where we have large buildings, also a church, a very large one. And we want to use this morphological data in the process of the terrain extraction. After digitizing here the data, you can then say File, Export Vector Data in a separate mode, and then I can here, this data here, I can export, I can define what format. I already did this here, so my data was already as a DXF, but when I measured here inside, by default, we offer here always WinPut, so you would need to switch to DXF and then define your output file, and then you would then export these morphological data into a DXF file. Same thing was done with this area. I digitized it and then I exported this area. And this is exactly what is mentioned here in chapter 5.1. So measuring morphological data in, typically you do this in stereo. This is the most accurate way to extract, in this case, these informations. Especially, of course, break lines are 3D lines, so of course stereo measurement makes here the most sense. Other break lines don't help us much in our process. And exclusion areas to exclude buildings in this part. And you could also measure single points, surface points, or form lines, which I did not do here in this video, but this would be also possible to generate. So after we did this preparation and saved the data in DXF, store each type of data in a separate DXF layer. This is exactly what we have done. Then we can now start the Match T or the Match 3DX process.